Rightio, g'day students. Today we're going to be looking at linear graphs. We've looked at the linear equation and then we're moving on to sketching that onto a graph today. So the point of today's lesson is to determine the slope and the intercepts of a straight line graph from both its equation and its plot using the general formula y equals a plus bx. We'll also try to construct some straight line graphs using both with and without the aid of technology. So when we have a look at a graph, you'll notice that it has four quadrants. It'll have the quadrant 1, it'll have two positive values, and the x and the y values will be positive in quadrant 1. Whereas we have a look at quadrant 2 over here, the x value will be negative. Get it right, Mr. Beasley. And the y value will be positive. So we're looking at quadrant 2. So it's negative, positive. And then we have a look at quadrant 3. Well, both the x and the y value here will be negative. And the quadrant 4, it will be a positive x and a negative y in this case because it's below that line, so it's below 0. Okay, when we want to think about our linear equation and putting it onto a graph, we think about the range. That's all the values along the vertical axis on the plane here. So if I have a look here, we're going from -2 up to +4, for example. And the domain is all the values along the horizontal, so we're going from -4 up to +2 here for this domain. So last lesson I gave you an example of a mobile phone plan, and we said that the cost of a 5-minute phone call was $3 and the connection fee was $1, and we wanted to work out the cost per minute. And we said, well, see, the cost equals 1 plus the number of minutes times that cost per minute. And we had to solve for x over here, which we said was the cost per minute, and that's the rate. Now keep that in mind because that's important when we come back to the gradient later on. So what I've done here is I said, okay, we've got a 5-minute plan and it cost us $3. Now we can use that linear equation to get a range of values. So for example, if I use this linear equation, I'm looking at my x value here, so our x-axis and our y-axis. We've got our x coordinate, which of 1 minute. And so if we've got 1 minute, and then that's the flag fall or the initial fee, and then we're going to say plus 1 minute times 40 cents per minute. So if you have a 1-minute phone call on this phone plan, you charge $1.40. However, if you're on the phone for 10 minutes, well, you've got that $1 and then it's 10 times 40 cents. So that'll get you a total of $5. So the domain here is what, 0 to 10? And the range is going to be 0 to 5 pretty well, especially when we draw this on our graph. So when we want to sketch this on a graph, we're going to consider putting our values in a table. That's going to be an x coordinate and a y coordinate. So what I want to consider with you is considering the scale of the x-axis and the scale on the y-axis. So we've got a graph here of 15 by 15 squares, and we want to try and take up the most space that's possible, I suppose, to make it still look all right. So we start our graph off at 0, 0, and we're going to go across 10. Now, because it's 15 squares, it's only going to be able to fill in 10 of these, so 6, 7, 8, 9, 10. And then if we go up, I think we can change our scale a little bit. So that could be 1, that could be 2, that could be 3, that could be 4, and that could be 5. And so what we're trying to do is fill the space and use as much of the graph as we can with using a regular scale. So now if I have a look at this graph, I've got a series of 3 different coordinates. So I'm going to look at this one. If I've got an a value of x equals 1, so I'm on this line somewhere, and then y equals $1.40. Well, I know that's $1.50 there, so $1.40 has just got to be under it. So I can draw a little dot or a little x. And so let's have a look at number 5 now. And we're going x equals 5, so I'm on this line over here, and I'm reading up to 3. So I want to put that little dot on 3. I think I just missed that. I wonder what happened there. And then I'm going to go over to 10, and I'm going to go up to 5. And what we should see is that's a straight line. Now that's going to be hard for me. I should really use a ruler, but it's a bit hard on the computer. When you do it, please use a ruler. Now we can check your sketch with technology. And for example, we can use Microsoft Excel. So when you do this, you can just select your different values and put them into a graph such as this, and just select that graph and then choose your XY scatter and insert that. And what you should appear is a graph with a straight line on it, and this is the linear equation graphed with technology, and you can use that to compare pretty quickly with your graph that you've sketched. Now we can think of the linear equation, and it has some important parts to it. So first of all, the x-intercept. Now the x-intercept is where the line crosses the x-axis when y equals 0. So that makes sense, that if that equals 0, the line's going to cross this axis here. So it may go through there, and so that would be our y-intercept. Now if we have a look at the next one, A over here, or that C over there, depends which expression we want to use. So that's now our y-intercept. So that's where the line crosses the y-axis when x equals 0. And that makes sense because that should be a 0 where those 2 points. Because this point here is generally called the origin, and that has the coordinates of 0, 0. So we now know where the x and the y intercept is. Now I asked you to keep in mind our rate of 0.4 for our phone call. This is going to appear as a slope on the graph, and this will be the direction that it travels. So this is a positive slope here. If I were to have a slope that ran this way, that would have a negative value. So if we have a look here, finding the gradient, first of all, let's describe those different ones. So when the slope goes down from left to right, so we start from here and we finish reading over here, you can see on the green one we're going down, and so that's when b is less than 0. Now when b, or the slope, is greater than 0, that's going to go up. Now if the slope, or b, is just 0, it's going to be a straight line, and if it's infinite, it's going to go straight up. So there's a strategy that we use to find the gradient, and that's this aspect here of the linear equation, and we describe that slope as the letter B in the linear equation, and it's the rise over the run. Now rise just means how far do you go up, and run is how far do you go across. And if you have a look at our two coordinates, we read from left to right. So our x1 and our y1 coordinates are on the left, and our x2 and y2 coordinates are on the right hand side of the other coordinates. So we're going from left to right. So the formula is y2 take y1 over x2 take x1. So let's see, we want to see that's ends up there and it starts there. So we're just saying y2 take y1, and then we're going to say divided by x2 take x1, and that should give us a number, and that will describe the gradient. So if we have a look at this slope here, so here's our phone call question. we've got a rise and a run here. So we've got x1, and we've got a y1 there, we've got an x2 there, and a y2 there. We've got an x3 there and a y3 there. Now I'm just going to ignore that one for the moment for this equation, but you can do any points along this line and you can choose those two coordinates, whatever's easy to pick I would choose. And so this one looks easy, I'm going to go with that one, and this looks easy, so it's going to be easy to calculate rather than using a decimal. So all I'm going to do is substitute in my second y coordinate. So here we are on the y-axis, and it's the top number, so it's y2, and we want to take away y1, so here we are on our second point, so that's 3, so 5 take 3 is 2, and then we're going to look at our x values. So here's our x2, here's our x1 for this case, and so it's 10 take 5. So we're going to get a slope of 2 over 5, and if we convert that into decimals, that's 4/10. So we can say that the slope of this line here is 4/10, and remember we said that the rate was 40 cents a minute too, so you can see how that relates directly to this line on the graph. What we're doing here, students, is just using some technology, so Microsoft Excel, to try and graph that linear equation into a straight line. So what I want to do is just put an x value and a y value. Now I'm just going to go from -3 to +3 just to graph this. So let's set that pattern and see if that goes up nicely. And then I'm going to write a few different linear equations and graph them. So I'm going to first of all just do this line here, and let's say y equals the same value as x. So let's have a look at that, and we'll copy that across. You can see that as we go across one, we're going to go up one. So we're going to insert a scatter plot, and we can do it that. And you can see that's a nice straight line. If this was a square, that line would be going up at 45 degrees. So let's just move that off to the side. And now let's call this line y2. And this time we're going to say this equals the negative value of that line there. And you can see, well, the -3 is +3. So let's graph that line. And what I'm going to do is just be a little sneaky and drag that down there. And you can see that the orange line is the new gradient. Let's just do a couple of others. So y3 this time. And we're going to say equals 2 times, I need to put the equal sign, equals 2 times x. And we'll enter that. And then we need to graph that, so I'm just going to drag that down, and I might just delete this orange one because that's getting a bit confusing. And you can see that the y equals 2x line is a bit steeper. The last one I want to do is just have a look at changing the plus value in the linear equation. So we're going to go equals x, and let's say +2, and then we'll move that across, and we'll graph that one. Oh, I have to be doing it again because I deleted that line. So we're just going to insert charts. And we've got a bit of a mishmash here, but let's see what we can do. We're looking at y4 in this case, and you can see the effect of adding the +2 is to move that intercept value up. So it's not going to go through the origin anymore. And you can see that that makes sense. When x equals 0, y is equaling +2. If I were to change that, and I could let's say, take away 6, I can quickly redraw that, and we'll have a look at that new x-intercept, and you can see that that's the y-intercept, and you can see that it's crossing that line down there. Another quick way to check your linear equations, folks, is just to use good old Dr. Google. So if I'm going to say y equals 2x plus 5, you'll notice that it'll automatically graph it for you. So that's a nice thing. You can zoom in and out, of course. So that's another example of using technology to check your work. So another way we can plot a linear equation into technology is just using your Microsoft OneNote app. So y equals 2x. Let's see what happens here. So I'm selecting that, and I want to plot that in 2D. And I can see something's happening here that's not right. So I'm going to play with that y value and see if that's going to work. Y equals 2x, and try and plot that and see if that's working a whole lot better. So I wonder why that messed up in the first place. So finally, can you determine the slope and the intercepts of a straight line graph from both its equation and its plot, which is y equals a plus bx? And can you construct a straight line graph using both with and without the aid of technology? When you've done that, we've got some questions for you to do. We've got some simple routine, some complex routine, and one complex non-routine for you to show your mastery of this subject.